Alright, so if you're watching this video, I wasn't able to make it into class today, but I still wanted to make sure you guys had the lesson. The substitute should have handed out notes for you guys to follow along with this. As we go through this, please write down whatever I'm writing down into your notes so that you have them as reference for the worksheets a little bit later. We're going to continue talking about exponential functions today. Yesterday we played around with graphing them and using function notation to evaluate. Today we're going to start off by looking at the standard form of exponential equations. Our standard form for exponential equations is going to be right here in the box. Y is equal to a b raised to the x power. A is going to be our start value. We can think of it like our y-intercept from our linear functions. B is going to be our growth factor, how much our exponential is growing. And x is still going to be our input, our x value, or our domain. Whenever we have a b that is greater than 1, we say that's going to be growth, and it's going to be an increasing function. It's going to go up like this. And anytime that b is between 0 and 1, it's going to be decreasing, and we're going to call that decay. So one thing that I want to start out doing is by comparing linear functions to exponential functions. By now, from doing the homework last night, you should have a good idea of what an exponential function looks like. So, if we are comparing linear and exponential functions, I made a little chart for us to help keep track of things. So first off, what does it look like? A linear function is going to look like a straight line. A line or a straight line. An exponential we talked about yesterday looks like a curved line. With a linear function, since it is a straight line, its rate of change or its slope is going to be constant. But we looked in the paper folding activity yesterday with the exponential that it did not go up by the same rate every time. Its rate of change, we say, varies. Right? Talking about domain, a reminder that the domain is the input values, the x values. Our domain for a linear function is always going to be all real. The same thing is going to be true for exponential. It will be all real as well. No matter what x value we plug in, it will give us some sort of output for our exponential function. When we talk about range, since the linear function is a straight line, it also will have a range of all real. Now, if you looked at your exponential, you will notice that its curve tended to level off. That place where it levels off is called an asymptote. And with that asymptote, we aren't going to have any values that are below that asymptote. So our range is going to be limited by the asymptote. And the asymptote is that line that this is going to get really, really close to, but not actually touch. Our linear functions do not have an asymptote. Our exponential functions will have an asymptote. Alright, in linear functions, since we are multiplying by a constant factor, is really doing repeated addition, whereas yesterday with the paper folding activity, we said that our y value was being multiplied by 2 every time. So an exponential function is repeated multiplication. And if you need to pause the video at this point to make sure you have all the chart down, you may do so. Alright, so one thing we need to talk about is how to determine whether something is exponential, linear, or neither. So on our next sheet of notes, and I'll zoom out a little bit so that we can see, we have tests for whether something is exponential, linear, or neither. If it's exponential, we're going to use division. When I talk about third term and second term and first term, we're talking about the y values. So what we're going to do is we're going to divide the third y value by the second, and we're going to divide the second y value by the first. And when we do so, we will, if it is exponential, come out to be the same number. If it comes out to be two different numbers, if let's say we got a 3 here and a 2 here, it's not going to be exponential. But if we got 4 and 4, then according to our test it would be exponential. So with exponential, we are dividing. For linear, we're going to do something similar, but we're going to use subtraction. We're going to subtract the third term minus the second term, and the second term minus the first term. And if that comes out to be the same, it's going to be linear. Now, if we do both of these tests and neither one works, we aren't going to classify it as anything yet. There are all kinds of other functions it could be. It could be quadratic, logarithmic, absolute value, anything like that. But for right now, we're just worried about exponential and linear. So if it is neither exponential or linear, then all we would write is neither, and that's when both methods fail. So if we look at the example on the next slide, we have a couple tables. So if we were to test for exponential, we would need to divide the third term, remember we're talking about the y's, divided by the second term. So in this case, 8 divided by 4, and we would need to do the second term divided by the first. So 8 divided by 4 is going to be 2. 4 divided by 2 is also going to be 2. Alright, so we can already see that this is going to be exponential. We can't have a function that is both exponential and linear. So once we have one test that passes, we don't need to test for the other. Let's go down and test the next one. If we were testing for exponential, we would need to do 7 divided by 5 and 5 divided by 3. Alright, we can already see that these are going to come out evenly, and these are not going to be the same. So let's try our linear test. If we do 7 minus 5 and 5 minus 3, for both, we should get 2. So that means this function is going to be linear. Let's test one more. If we do division on this next one and did 4 divided by 1 and 1 divided by 0. 4 divided by 1 is going to be 4. We know though...
Hannah Wellborn and Ellie Eller, please come to Miss Wellborn's room. Hannah Wellborn and Ellie Eller, please come to Miss Wellborn's room. Thank you.
Sorry, we had the intercom there. 1 divided by 0. We can't divide by 0. So even though we know that we can't divide by 0, we know it's not going to be equal to 4. So it's not exponential. To test for linear, 4 minus 1 and 1 minus 0. 4 minus 1 is 3, and 1 minus 0 is 1. So since this one passes neither the exponential or linear function, exponential failed, linear failed, we're just going to simply say that this is neither. And that would be our answer if we were asked to tell whether it was exponential, linear, or neither. Right. Before we move on to the next section, the substitute is going to hand out a activity for you to help determine linear and exponential. I'm going to give you guys about 20 minutes to work on this, and when you are finished with that, let the substitute know. And after the 20-minute mark, I'm going to have the